The first long question on paper 1, we have a taxation question, pretty much a junior cert question. 40,000 on the first 20%, and then the remainder at 40%. So if we earn 54,000 and we pay 40 at the higher rate, we're going to pay 14 at the lower rate. Hard to believe this came up on a leaving cert higher level paper, but there you go. 20% of 40,000 is 8,000, and 40% of 14,000 is 1,400 by 4, which is 5,600. That gives gross tax of 13,600. For your gross tax, we take away our tax credit, which is 1,775. This will give me net tax of 11,825, leaving my salary as 54,000. Take away 11,825, which gives 42,175 euros. A nice easy intro to this 6-part question. So 4 of them are worth 10 and 2 of them are worth 5. The second part, Fia and her partner take out a 25-year mortgage, monthly repayments. So straight away I'm just going to find out the amount of payments. 25 by 12, so we're going to have 300 for N or T. The monthly interest rate is 0.279 of 1%, so 0.00279 as a decimal. And we have the repayments here, 1647.75, and we're asked to write down the present value of each of the first 3 monthly payments. My present value is the payment 1647.75. The present value in years time be worth less, so we're dividing by a number greater than 1. So it's 1 point the interest rate, or 1 plus the interest rate, 0.00279. The second one will be 1647.75 divided by 1.00279 squared, and the third one will just be the same thing, to the power of 3. This could help you set up 279. I've left out in the second one. This could help you set up a geometric sequence for the sum of all the payments. We're asked to work out the amount of money borrowed, so we write down the amortization formula. The repayment A is equal to the amount we borrow times the interest rate times 1 plus the interest rate to the power of t, and then on the bottom we're going to have 1 plus I to the power of t minus 1. So from this point it's just calculator use. So we fill our values in. 1647.75 is equal to, we don't know what P is, we're looking for it, but we do know the interest rate is 0.00279, and 1 plus the interest rate is 1.00279 to the power of 300, all divided by 1.00279 to the power of 300 minus 1. Probably good maths to type the top 2 into your calculator and divide by the bottom 2. So that's going to leave 1647.75 is equal to, I would take all the numbers here, 0.004925 087 times P. So P, the amount that we've borrowed, is working out to be 334. We want it to the nearest euro, 334,562.62. So that's going to be 334,563 for the amount that we borrowed on our mortgage. The next part, we have, they're putting their money into a savings account and they leave it there for a number of years, and we can see the function here is 5,000 e to the power of 0.014. So we're asked to use the expression to answer the following three parts. So use differentiation to find the rate at which the money in the account is increasing after 3.5 years. So differentiating 5,000 e to the power of 0.04t. So we're going to get f prime t to be 0.04 times 5,000 e to the power of 0.04t. And if we sub in, what's t, 3.5, we're going to get 0.04 times 5,000 to the power of 0.04 by 3.5. 3 fours are 12 and 2 14, so 0.14. And if we type this into a calculator, we get 230.05. And this is the nearest euro per year, and that's in euros per year. And we're asked correct to the nearest euro, so 230 euros a year for the rate of change. Part 2, we're asked to use integration to find average amount. So just bring that memory of 1 over b minus a. So we do everything the same. We're going to integrate 5,000 e to the power of 0.04t. And we're going to do it over 1 over 5 minus 0 the first 5 years. So we're going to get a fifth. And if we integrate 5,000 e to the power 0.04t, we have to multiply by 1 over the differentiated power, 1 over 0.04. And 5,000 divided by 0.04 works out to be 125,000. So we have a fifth of 125,000 minus, sorry, just 25,000 e to the power of 0.04t, and then the minus comes in next, so we're going to get 1 over 5, and this is between 5 and 0. 1 over 5 times 125,000 e to the power of 5 0.04s is e to the power of 0.2. And then we'll have e to the power of 0 is equal to 1, so just minus 125,000. Put in e to the power of 0 maybe, just to tidy it up. And getting a fifth of this gives me 5,535 for the amount, the average amount, correct to the nearest euro. This is giving us 5,535 correct to the nearest euro. For part 2 and part 3, the annual rate of interest for this account. So that is the percentage in the amount of money in the account over the course of 1 year. Well, if we take t is equal to 0 and t is equal to 1, f of t, f of 0 is equal to 5,000 e to the power of 0, which is 5,000. And after 1 year, we're going to have 5,000 e to the power of 0.04 just times 1. That's going to give 5,204.05. So the percentage increase, it increased by 204.05. It started at 5,000. And if we multiply by 100 over 1, we get the percentage as 4.0 over 2 decimal places, so 0.8 to 2 decimal places to conclude question 7.